In this video, we detect a voltage drop, we watch a microprocessor in its natural environment, we do surgery on a transformer, and we watch music emanating from an egg. This is an egg-shaped music player that should have some nice color effects while playing music, but it seems a bit tired, because when we press the power button we see an orange and a blue LED light up, but as soon as we release the power button they go out and the egg goes back to sleep. Let's open it up and see what we can do to make it play again. It looks like there are some screws behind this silver colored foil, so we're going to have to remove it, hopefully without tearing the foil. Nice and easy does it. Well, that went well. The foil is still in one piece and we have clear access to 4 screws. Let's disconnect the speaker so we can check the PCB separately. Let's get the PCB under the microscope to check for any blown components or damaged tracks. I couldn't find anything on these EF609 ICs, so if you have any information on them, please leave it in the comments. This group of capacitors is probably a power supply of some sorts, with the EUP7961 being a voltage regulator. This might well feed the microprocessor. Loads of ceramic capacitors, which I tested for shorts to ground by putting the multimeter in continuity mode, connecting one probe to the ground and check if there is any capacitor beeping on both ends, but they turned out to be all fine. A little bit of dirt here and there, but probably not corrosion. Let's clean it anyway. This large chip is the microprocessor, which has some flash memory to store the software of the device. Hopefully that didn't get corrupted, because there is probably no way to retrieve the firmware anywhere. Let's start the debugging process by measuring the voltage on a microprocessor. According to its datasheet, it needs 2 to 5 volts to run. So when we press the power button, it gets enough voltage to run, but when we release the power button, it immediately drops to an insufficient level. Let's trace back. This voltage regulator might very well be providing the microprocessor with its power, so let's measure that as well. Same result, good voltage when the power button is pressed, but drops when the power button is released. One more step back is the input capacitor next to the power input. Substantial voltage drop there as well. And in this moment I realized that I went into the deep end immediately before trying the obvious. What if the power supply is failing? Let's try to start the egg with the bench power supply. Right, it seems to work fine now. Oh dear, one good reminder to not dive too deep too early. Well, we want to find the failing component, so let's open up that power supply. Clearly that was not made to be serviced. So here's the output capacitor, which looks like it's a tiny bit bulging. Let's remove it from the board and test it. So that's 680 microfarads at 10 volts. And that top is definitely rounded, which should be flat. So it's bulging. Well, there you go. That is way less than what it should be and a very logical cause of our problem. Since we will not be able to get this transformer back together again because of its non-serviceable design, we are going to replace it. I have a box of spare transformers and this one is 5 volts, 1.5 amps. Let's connect the original wire to it so the power plug will fit. Thank you so much for watching this video. Please consider a donation using the thanks button or join the channel and support me keeping electronics from ending up on the scrap heap by pressing the join button. Like and subscribe if you already haven't, and I hope you will join me in the next video. Bye then!